So in the previous video, we were doing an example. In this example, we have Z1 and Z2. In Z1, your radius 1 is 2 and radius 2 is 3. Theta 1 is 30 and theta 2 is 135. So we have to find Z1 times Z2. Since Z1 times Z2 using the previous formula is the product of two radii. So the two radii are 2 times 3. So I have taken the product of 2 times 3. And we have to add theta 1 and theta 2 inside cosine plus iota iota times sine. Okay, so theta 1 and theta 2 are 30 and 135. I have added 30 and 135 inside here. I have plugged their values. If I add 30 and 135, I will get 165. So here I have 6 times cosine 165 degrees plus I sine times 165 degrees. Okay, this is your answer in this example. If you want to see this example geometrically, you can make the diagram. You can make a complex plane, and first you will represent this number on the complex plane. Then you will represent this number on the complex plane. Then you will represent this number on the complex plane. And you will see the relationship of these three numbers. In other words, you have to find the geometric inside of these things. So our first complex number is have radius 2 and angle theta 30 degrees. So first of all, I will make an angle of 30 degrees and then I will draw a vector of length 2. So at 30-degree angles, I have drawn a vector of length 2. So that means this is my Z1. This is my Z1. In order to draw Z2, I have to draw another vector whose length is 3, but whose angle is 135. So if I draw an angle of 135, it will be here. Okay, so here if I draw a vector of length 3, it will be here. So now you can check that I have drawn two different vectors, the one with length 2, the other with length 3, the one with angle 30, the other one with angle 135, and they are in different quadrants. Now what we have to do, we have to multiply this vector with this vector, and after multiplication you will check that my answer is this one. That means I will get a new vector whose length is 6 and whose angle is 165. Now if I draw an angle of 165, so it will be bigger than 135 but less than 180. So this angle will be somewhere here. So your new vector will be here. You can check that its length is 6. It is double of the length of this one. You can check this length is 2 times, this length is 2 times the length of this one because it is 6. Because the resultant vector has length 6 and whose angle is 165. So its angle is 165. You can check from here. It's 135 plus 30, so it's 165. So here the angle should be 30 because if I add 30 degrees into 135, I will get 165 degrees. So that means this is the geometrically correct diagram of the product of the complex numbers. Now here are some exercises for you to do. You'll be given Z1 and Z2. You have to find their product, and then you have to draw those complex numbers on the complex plane, and you have to draw their product also on the complex plane, just like I did in this diagram. So in the first question, you have to multiply Z1 and Z2. And in the second question, your Z1 and Z2 are changed. So here are the two different examples which you can do if you want. What you have to do, you have to find the product of Z1 and Z2. First of all, you'll make the product of these two, and then you will make the product of these two. And in both of the questions, you have to find their diagram also. You have to represent on the diagram both of the complex numbers and their product as well.